Assalamualaikum warahmatullahi wabarakatuh, and for our heat and mass transfer mini design project, we'll be designing the heat exchanger. This is the list of our group members. For schematics part of question B, for question B, the vendor is proposing that the two new unit heat exchanger could be operated in parallel such that each unit would process exactly one half of the flow rate of each hot and cold stream in counterflow manners. From the schematics, two heat exchanger is arranged in parallel arrangement with each half of cold and hot stream is processed at each heat exchanger. Counterflow heat exchanger are inherently more efficient than parallel flow heat exchanger because they create more uniform temperature difference between fluids over the entire length of the fluid path. Moving on to the calculation part. Before doing the calculation, there's a few assumptions need to be made to ease our calculation. One of the assumptions that will be assumed in this calculation are the heat exchanger operation is at steady state and the heat transfer to the surrounding are negligible. It is also assumed that the fluid properties are constant with no fouling occurs. Lastly, the tube diameter for all of heat exchanger are considered as the same. Thus, from the assumption, we can compute the overall heat transfer and the heat capacity of both hot and cold stream. Thus, from the heat capacity of hot and cold stream that is obtained from the previous calculation, we decided that heat capacity of hot stream as the minimum heat capacity since the heat capacity of hot stream are smaller than heat capacity of cold stream. Hence, the heat capacity of cold stream is regarded as Cmax. Then, we compute the maximum heat transfer rate by using the formula of Cmin times by the temperature difference between hot stream in and cold stream in. Then, the number transfer unit NTU can be calculated. Finally, the actual heat transfer rate can be calculated, which is 223.02 kilowatt. From the calculated actual heat transfer rate, the outlet temperature of cold and hot stream can be calculated. After the calculation, we found out that the outlet temperature of cold stream is 23.29 degrees Celsius and the outlet temperature of hot stream is 75.84 degrees Celsius. Now, for our comment for question B, the hot stream outlet temperature is 75.8 degrees Celsius if we use the heat exchanger in parallel, while the existing heat exchanger is 69.8 degrees Celsius. This shows using the new system of two parallel heat exchanger cannot do the desired cooling and the difference is only about 6 degrees Celsius. Increasing the surface by increasing the tube diameter and length so that the new surface area will be more than 5 meters squared. If the tube diameter are kept the same, assuming the tube diameter equal to 5 cm, so the new length will be more than 0.32 meter.
Continue our mini design project with question C, which is suggest another type of heat exchanger that could replace the existing heat exchanger with the same performance as question A. Write complete proposal to explain your selection with supporting drawing and calculation. So, suggested heat exchanger that we can design is shell and tube heat exchanger. This is one of the shell and tube heat exchanger, which is straight tube heat exchanger and only one pass. The justification of selecting shell and tube heat exchanger for this project is one of it is wide range of operation pressure and temperature. Second of it, it is a typical type of heat exchanger that are designed for large scale and industrial purposes. And thirdly, it is easy to maintain and clean due to its components that are easy to be removed.